Can you hear me? Mukti?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So we are going to periodic classification. In class 10th, you learned little bit on periodic table. Little more we'll be learning. Little more we'll be learning in class 11. Mendeleev's periodic table you learned, in which it stated that Mendeleev's periodic law, which stated that physical and chemical properties of elements are the periodic functions of their atomic weights. But Henry Moseley later found out that rather than this atomic weight, the physical and chemical properties of elements are the periodic functions of their atomic number. He plotted a graph between, by his X-ray diffraction studies, he plotted a graph between square root of frequency. He plotted a graph between square root of frequency against atomic number, and he got a straight line. So by analyzing X-ray spectrum, Henry Moseley came to the conclusion that Puneet Pete, what happened? Any problem? So he analyzed that not the atomic mass, but atomic number is the most important property. Physical and chemical properties of elements are the periodic functions of their atomic number. And we have so many elements, and each element is characterized by their atomic number. Atomic number means its electronic configuration that comes to our mind. Now, this electronic configuration, how it is showing the characteristic properties of elements. What all properties the elements have? Everything based on their atomic number and their Atomic number means electronic configuration. Higher elements means with higher atomic number, they are very unstable. Now, periodic table is not complete, still the elements are discovered. So, these elements means with a higher atomic number. Higher atomic number elements are not very stable. Only highly sophisticated laboratories. Which countries have highly sophisticated laboratories? Technologically advanced, US and Russia. So here only they could analyze, they could make out this, they could discover this new elements. So if US discovers an element, they say that this element is to be named after us. That is their scientist's name. That time Russian people say, no, this is discovered by us, so our name should be put for this element. So again, contradictions and conflicts. So IUPAC gave a special rules for naming these elements. So naming of elements had been the privilege of the discoverer. New elements with high atomic number are so unstable that only minute quantities are obtained. Only highly sophisticated laboratories in the world can carry out their synthesis. For example, I told you, both Americans and Soviets claim the credit of the element with atomic number 104. Americans named it Rutherfordium because Rutherford is his scientist. Americans named it Rutherfordium, whereas Soviets named it as Kurchatovium. Kurchatov was their scientist. To avoid such problems, IUPAC made a systematic nomenclature for atomic numbers greater than 100. So first we will see that atomic numbers, how to name those higher elements with atomic number greater than 100, 101, 102, 103, etc. For that, if it is 0, then you have to take nil. So, Puneet Pette, any problem? Puneet Pette, you want to say something? You are raising the hands in between. If there is 1, then UN, un. So the symbol we use is U. So you write one box, digit, name, abbreviations. Digit, name, abbreviation. Digit, name, abbreviation. For 0, nil. For 0, nil and N. First letter, that is the abbreviation. For hydrogen, we say H. For helium, we say He. Like that, nil, N. 1, un, U. 2, by, B. 3, Try T. Try T. 4 quad Q. 4 quad Q. 5 QUAD. QUAD quad. 5 pent P. 6 hex H. 6 hex H. 7 sept S. 8 oct O. 9 N E. So in this way, each number, for example, 104, 104, Americans wanted to name it as Rutherfordium. Soviets wanted to name it as Kurchatovium. IUPAC, to solve the problems, IUPAC named it according to the number 104. 1, un, U. 104. Un, first letter U. 0. So here un, nil, quad. Un, nil, un, nil, quad. Then last में you have to put one IUM, unilquadium, and you abbreviate as UNQ. Its symbol is UNQ. Symbol is UNQ. That is the symbol. Write one question. What would be the IUPAC name? What would be the IUPAC name and symbol? For the element, symbol for the element with atomic number 120, with atomic number 120. 120. Un, by, nil, un, by, nil. Un, 1, by, 2 के लिए by, 0 के लिए nil. Un, by, nil. Last में IUM. Unvinilium. And its symbol will be UBN. Symbol will be UBN. 118. 118. 118. Above 100 is the problem. 101, 102, 118, 120. 118. Unoctium. Unoctium. Unoct. IUM. IUM. Unoctium. That is UUO. UUO. Unoctium. Now, let's do the period-wise study. Period-wise study. Can you see the periodic table? No. I'll do the screen sharing. Now you see hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton, rubidium, strontium, yttrium, zirconium, niobium, molybdenum, technetium, rutherfordium. Can you read it? Can you see the periodic table? Mukti, if you are seeing, please raise your hands. All right. Okay. Thank you, Sahil. Of course, in this periodic table, these first two, first one and this, you know that horizontal ones are rows and vertical ones are called columns. Horizontal ones are rows, like this, rows, and vertical ones are columns. How many vertical columns are there? 18 vertical columns are there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 columns are there. These are called groups. Horizontal rows are called horizontal lines. These are called rows. Vertical ones are called columns. So in this first group, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. This is first group. Their last electron enters to s orbital. Similarly, second group, their last electron also enters to s orbital. But here 13th, 14th, 15th, 16th, 17th, 18th, their last electron enters to p orbital. When you write the electronic configuration, you will come to know the entry of the last electron. So, if the last electron enters to s orbital, we say s orbitals are progressively filled. So, in first group and second group, last electrons are entering into s orbital. We say s orbital is progressively filled. What is the sentence? S orbital is progressively filled. So we call them, this first group and second group, we call them S block elements. S block elements. Can you see the cursor moving? Mukti, if you are seeing the cursor moving, please raise your hand. All right, cursor moving. Okay, right. Thank you. Pragya Diwan, thank you. In this 13, 14, 15, 16, 17, 18, the last electron is entering into a p orbital. So we call them p block elements. We call them this 13, 14, 15, 16, 17, 18. Actually, the seventh period is the seventh period. This is first period. This is second period. Third period. fourth period, fifth period, then sixth period, cesium, sixth period, then seventh period. Seventh period is actually incomplete. The studies are still going on. And these are Rutherfordium, of course, okay, then dubnium, seaborgium, borium. These are newly discovered. Newly discovered, still the controversies are going on. So IUPAC has named it according to these rules, that is UUN, UUO, like that. In this periodic table, they have printed this letters, that is T, S, O, G, L, V, M, C, F, L, N, H, like that. These are under controversy only. From here it is this empty, the shade change you see, these are under controversy, conflicts only. Okay. So these are S block elements. S block element means S orbital is progressively filled. And here 13 group, 14, 15, 16, 17, 18th group, they are P block elements. So yahan se through this P orbital is progressively filled. P orbitals are progressively filled. So we call them P block elements. We call them P block elements. Now D block. Scandium to zinc, yttrium to cadmium, and lanthanum to lanthanum here. You cannot see La written here. Actually, this La is to be written here. Not only La, all these blue shaded elements are to be packed and to be kept inside this box. But there is no space to include all these 14 elements. So lanthanum is normally written here. So then all cerium to lutetium, all are to be very well packed. Pichku karke udhar rakhna tha, jagah nahi hai. So we are writing it separately. So we call them, as lanthanum is the head of the family. We call them this. We call all these fellows lanthanoids. We call all these fellows lanthanoids. We say Sharmas. The family members of Sharma, we call Sharmas, like that. Here, lanthanoids. Similarly, so you know these categories, scandium to zinc, D block, where D orbital is progressively filled. The last electron enters to a D orbital. Similarly, yttrium to cadmium, D block element only. Here, scandium to zinc, 3D orbitals are progressively filled. Yttrium to cadmium, 4D orbitals are progressively filled. Lanthanum, I should write La over there as a head of the family. Lanthanum to mercury. Lanthanum, yeah, lanthanum, what you can call in any way, lanthanum to mercury, yeah, lanthanum to mercury. But the family members are called the lanthanoids. Similarly, here I should have written actinium, slight sea green color here. So all these 14 elements from thorium to actinium is to be written here AC. You should write AC here. In all periodic table, you will see AC. If I take another periodic table, here it is AC written. Here it is AC. Just above that LA. LA is written. LA, lanthanum. Below that AC, actinium is written. But in this periodic table, what I have shown on the screen, it is written along with that 14 elements. So here, actinium is to be written here, And from thorium to lawrencium, this thorium to this lawrencium, the sea green color what you are seeing, these are to be packed, पिचकू करके ये box में, इसी box में रखना था. This would have been kept in this box. Okay, all these 14 elements should have been kept inside this box, but there is no space for these 14 elements to be shown, so it is separately kept here. But these 14 elements, or including this 15 lanthanum, these are called lanthanoids. These are called lanthanoids, and these are called actinoids, as actinium is the head of the family. Actinoids. So these are called lanthanum as a head of the family, and all these blue shaded ones are called lanthanoids. Here F orbital is progressively filled. We call them F block elements. Similarly, actinium as a head of the family, actinium should have been written here. Not only actinium, all these elements should have been written. Chote 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 करके इसके अंदर घुसाओ. So these are called actinoids, thorium to lawrencium, and with the head of the family, actinoids. So these are lanthanoids. These two things are called this blue and green, the sky blue and sea green. Sky blue and sea green, they are called F block elements because F orbitals are progressively filled. F orbitals are progressively filled. Okay. So block wise, that is the arrangement. S block, then the side P block, बीच में D block, and नीचे F block. All these are having different characteristics. For example, this D block are colored. Almost all of them are colored. ये zinc, cadmium, mercury colored नहीं है. फिर भी almost all are colored. Zinc completely filled d orbitals. Color means that is the after effects of unpaired electron. If there are unpaired electrons, it shows magnetism and it shows color also. Color is due to DD transition. We will be learning afterwards. So today we will be seeing the classification, that is S block, first and second S block, and 13 to 18 P block. Here last electron enters to P orbital, gallium, then indium, thallium. These all things, in all these elements, P orbital is progressively filled. Okay, I'm stopping. We'll continue in the next class. Thank you.